Hello and welcome to Mr. Tompkins Ed Tech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Trigonometry Recap and Extension. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. So we're going to be doing the Trigonometry Recap and Extension topic test from AQA. This particular test was requested by one of my subscribers, 100 subs, no vids please guy. So thanks very much for that suggestion. If you have any more suggestions for topic tests to do, please make a note of them in the comments. I'll see what I can do. Okay, so let's have a look at question 1. What is the value of sine A for this triangle? Okay, so I don't know how you remember your various trigonometric ratios, but I tend to use SOHCAHTOA as just a mnemonic to remember which way around everything goes. So we're interested in the sine of A, which is this one here. Sine is equal to, so the sine of my angle is equal to my opposite over my hypotenuse. Okay, so I need to know which side is which from this triangle. And if I want sine A, it's that angle there, isn't it? And then I label up my three sides relative to that side. Well, to that angle, sorry. So the longest side is always the longest side, that's the hypotenuse. And then the side opposite my marked angle is the opposite. And the side that touches my marked angle is the adjacent. So they're my three sides. So I'm interested in opposite divided by hypotenuse, which is this side, the 4 divided by the h, which is missing. Okay, so we need to work out what that missing side is. We have to do a lot of work for 1 mark here. Okay, so this side then is the longest side of a right angled triangle, and we can find it using Pythagoras Theorem. We can say that c squared equals a squared plus b squared. So in this case I've got 4 squared plus 5 squared, which is 16 plus 25 added together is 41. So my hypotenuse then is going to be the square root of 41. So it's going to be 4 over 41 then, 4 over root 41, sorry, which is that one there. That's an awful lot of work for 1 mark. Anyway, okay, let's move on. Question 2, work out the length of x. Okay, now again, let's just label up the 3 sides of our triangle first. So x is on the long side, which is the hypotenuse. Here's my marked angle here, the 31. So this side is opposite and this side is adjacent. So I know the adjacent side and I want the hypotenuse. So which ratio do I need to use? Again, I've got my mnemonic SOHCAHTOA to help me. Now I'm interested in the one that has got A and H in it, which is that one there, isn't it? The one in the middle, cosine. So writing out what the cosine angle is, cos of my angle is equal to A, the adjacent, divided by H, the hypotenuse. I can now sub into it what I know. So I know the angle is 31. So cos 31. I know the adjacent is 18. And I know the hypotenuse. No, I don't. It's x. So I've got cos 31 is equal to 18 over x. So rearranging for x, I've got x down here. I'm going to cross multiply it with that cos 31 up there. Rewrite it, make x a subject. So I'm going to get x is equal to 18, that hasn't moved, divided by cos 31. Time to reach for the calculator. Okay, so 18 divided by the cosine of 31. That is 20.9994, which I'm going to round up to 21.0. Unless otherwise stated, it's always good to put your numbers down to 3 significant figures. 21.0. Have I got a unit? Yeah, that's centimeters. Just take a moment to reflect and imagine that 21 in the triangle. Does it look about right? Well, we know it's the longer side. It's longer than the 18, but it's not massively longer. It looks quite okay in that triangle. It's always good to do a little visual inspection at the end just to double check that your answer looks okay. Okay, I think we're done. Let's move on. Question 3, work out the size of angle y. Okay, so I've got another right angle triangle. But this time it is the angle I need to find, that angle down there. But I'm going to go through the same steps as the last question. I'm just going to label up the 3 sides to start with. I usually start with the longest side, that's my hypotenuse. So my marked angle is down here. It doesn't matter if we don't know what it is. We still mark up the other 2 sides relative to that one. So this one again is the opposite, and this one again is the adjacent. So I've been given the opposite, I have been given the adjacent. So which trig ratio am I going to be using? Well, again, I've got my mnemonic SOHCAHTOA, and I think which one has got to do with O and A. It's that one on the end there, isn't it? TOA, tan. So I'm going to write down the ratio. Tan theta is equal to opposite over adjacent. Okay, so then subbing in the things that I know that tan y then is equal to opposite 23 divided by my adjacent 30. Right, so now to get y by itself, I have to kind of move this tan part to the other side, and the way I do that is use the inverse tangent. So I'm going to use the fact that y then is going to be the inverse tan of 23 over 30. So pulling up the calculator then, shift key to pull up the inverse tan, and then I'm going to type in 23 divided by 30, and I make that 37.476. Now again, it doesn't really give me a degree of accuracy, but I'm going to round it off to 3 significant figures unless otherwise stated. So I'm going to write down 37.5. 37.5. Now what are the angles here? I was already given it there, but I'd like to put it in anyway. Degrees. Question 4. We're told that AB is equal to AC, so this is an isosceles triangle. And we're asked to work out the area of triangle ABC. Now, you should know 2 formula for working out area of a triangle. The first one is just half base times height, isn't it? Kind of the basic area of a triangle formula. But there's also the trigonometric version of it as well that you should be aware of. The area is equal to half AB sine C. Okay, now this paper is on trigonometry, so you might be thinking it's the second one that we're going to be using, but I don't actually think that is going to be the case here because we're not given any angles, so it's not going to be this one we're using today. It's going to be we're going to be using our kind of standard area of a triangle amount. Unfortunately though, I know the base, here's the base, it's 14, but what is the height of this triangle? It's not immediately clear. I've got the slant height, that's 25 over there, look. And if this is an isosceles triangle, this perpendicular line I've written down here will cut my baseline exactly into 2, which means that that one there is 7. So what I'm going to do is I'm going to use Pythagoras theorem then to work out the height of this triangle, and then I can then work out the area after that. Okay, so using Pythagoras theorem, so my longest side is C and the other ones are A and B. It doesn't really matter which way around they go. So I'm going to say if C squared equals A squared plus B squared, then B squared is going to be my longest side, C squared, subtract A squared, which is going to be 25 squared subtract 7 squared. Okay, so what's that then? So 25 squared subtract 7 squared. That's giving me 576. So B then is the square root of 576. Let's hope it gives me something nice. Root answer 24. Does give me something nice. Okay, so B is 24. Does that look right in that triangle? Yeah, it looks about right. It's less than the longest side. I think that's okay. So now we know that the height is 24. We can go on and work out the area of this triangle. Then the area is a half base height. So that's a half times 14 times 24. Half of 14 is 7. 7 24s. What's that then? According to my calculator, that's 168. So my answer is 168 centimeters squared. Now, we could have used the other method as well. We could have used the 7 and the 25 to work out what this angle was here, then the angle C, and then use half AB sine C to work out the triangle. So that's another possible approach. You could have done that. But I think most people would be more comfortable with the first method. So yeah, up to you really. Question 5. Work out the length of the diagonal AB of a cuboid with dimensions 5, 12 and 15. So basically it's that long diagonal that's going all the way through the cuboid from one corner to the opposite corner. Now I'm going to show you a long way and a fast way of doing this. Let's start with the kind of the longer way method of doing it. Now I'm going to be using Pythagoras theorem again in this triangle. First off though, I'm going to make an extra line so it's a bit easy to see what's going on. So let me add a line across there. So that's going to give me this triangle down here, which is half of the base, isn't it? Now I could use Pythagoras theorem then to work out. Let's just move that ruler out of the way. Go away, ruler. I can use the Pythagoras theorem to work out the length of that longest side then, can't I? So let's call that point there C. Then AC squared is going to be 12 squared plus 15 squared. Right, so what's that then? 12 squared plus 15 squared is 369, and then square root that. Well, it's going to give me 19.2 in a bit. I might just leave it as that. Then AC then is the root of that then. So AC then is the root of 369. Okay, so now I know that this side here is root 369. I can then use Pythagoras again in the triangle ABC. So can you see that in there? It's this triangle in here. Look, it's kind of the one that's standing up on its side. Okay, so there's the right angle down there. So it's got shorter sides, root 3, 6, 9, and 5. So then the longer side, AB, I can find using Pythagoras theorem again. So AB squared then is my root 369 squared, which is going to get rid of the square root, plus my 5 squared. The root of 369 squared is 369, and 5 squared is 25. 369 plus 25 is 394. Okay, so then AB is going to be the root of 394, which is 19.8. To 3 significant figures. Okay. Now, that was the long way of doing it. I did say there is a quicker way. Now, in a cuboid, you can actually use an extension of Pythagoras theorem in 3 dimensions, and that says the diagonal in a cuboid is equal to, so AB squared is going to be the 3 dimensions of your cuboid squared added together. So it's going to be 12 squared plus 15 squared plus 5 squared. Okay, so what's that then? 12 squared plus 15 squared plus 5 squared. You see, gives me the same answer, 394. So then AB is equal to the root of 394. So if you can remember this kind of extension of Pythagoras theorem, you can actually do it a quicker way than working out one triangle and then the other, like I did in the example down here. Okay, let's move on. Question 6. ABC is a right-angled triangle on level ground. DB is a vertical mast of height 12 meters. The angle of elevation from A to D is 42, and the angle of elevation from C to D is 35. Now, it's always a good idea just to double check that all that information is already on the diagram, because sometimes it isn't. So the vertical mast is 12, and that's already on there. The angle of elevation is 42, that's already been given, it's down here, look. And the angle of elevation of CD is 35, and that's already been given. Okay, so all the information is already on the diagram. Oh, plus it's a right-angled triangle at ground level, and that's been given there. Okay, so all the information in the worded part is in the diagram, but it isn't always the case, and it's always worth just double checking that there isn't anything missing from your diagram. So we need to now work out the distance AC, which is that long distance there. So we've got trigonometry in a right-angled, well, in 3 dimensions, haven't we? So how are we going to work this out? So at the moment, we don't know anything about triangle ABC. Now we're going to need to know 2 things about it if we're going to work out that long diagonal. Well, we know it's a right angle triangle, so if we can find this side along here, and if we can find this side along here from those angles that we've been given, then perhaps then we can work out what that side AC is going to be. So we're going to be using 2 different triangles. I tend to draw the triangles out when I'm going to be using them. So I'll say, like, in triangle ABD, and it doesn't hurt just to do a little quick sketch. Pull that out of the diagram, makes it a bit clearer. So that one down there is the 42 degrees. That's A, that's D, that's B, and I know that the height then is 12. Okay, and I want to work out AB, which, according to my hypotenuse, opposite, adjacent of this angle, I'm going to be using A and O. So SOHCAHTOA, A and O is the tangent, isn't it? So I'm going to be using tan of an angle is equal to opposite over adjacent. So tan 42 is equal to the opposite, which is 12, divided by AB, which I'm trying to find. So then, rearranging that, cross multiplying that AB up there, and the tan 42 back down again, I'm going to get that the side AB is going to be 12 divided by the tan of 42. So reaching for the calculator, 12 divided by tan 42, I make that 13.3. Okay, that's going to be in meters, isn't it? That can't be right. Oh yes, it is. That's fine. Okay, so that's one triangle. Now the other triangle then is going to be triangle BCD, isn't it? So let's switch to that triangle now then. So in triangle BCD, now again, just drawing that triangle out underneath. There's the right angle. That's D, that's B, that's C, that's 35, that's 12, and I'm trying to find BC, aren't I? Okay, so again, here's my marked angle, here's the hypotenuse, this is the opposite, this is the adjacent. So this time I've been given the opposite, and I want the adjacent, so again it's tan again, isn't it? So tan theta is equal to opposite over adjacent, and this time it's going to be tan 35 is equal to my opposite, which is 12, divided by my adjacent, which is BC. Okay, so then working out BC, same way as before, switching these two around, I can say that BC is equal to 12 over tan 35, which is what? 12 divided by tan 35, that makes 17.1. Okay, right, we're not done yet though, are we? Because we've got one more triangle to look at. We've got triangle ABC to look at. Okay, so and finally, in triangle ABC, so that's the base, isn't it? That was the right angle up there. We don't know any of the angles, but we know we've got 13.3 and we've got 17.1, and we want to find the longer side, don't we, the hypotenuse. So we're going to be using Pythagoras theorem then, aren't we? So we're going to be using c squared equals a squared plus b squared. So we're going to take our two sides that we worked out, we're going to square them. So what's 13.3 squared plus 17.1 squared? 13.3 squared plus 17.1 squared. That's 469.3. So then we want to square root that then. And make that 21.7. So my side C then is 21.7 meters. Question 7. ABC is a right angled triangle. Use trigonometry and Pythagoras theorem to show that sine squared A plus cos squared A equals 1. Note that sine A squared is the mathematical way of writing sine A squared. Actually, they've written that bit wrong. This bit here, they should have written, note that sine squared A is the mathematical way of writing sine A squared. So that's just to distinguish it from the sine of A squared. Okay, so sine squared A is the way of writing sine A times sine A rather than the sine of A squared, if you see what I mean. Bit maths and all that. Right, so this is actually quite a famous result. Sine squared A plus cos squared A equals 1. It's something that you start using at A level. And we need to use trigonometry and Pythagoras theorem to prove it. Okay, that's an interesting question. So how are we going to go and do that then? Well, the angle A is down here, isn't it? There's my angle A. So, using SOHCAHTOA, let's work out expressions for sine A and cos A. So sine of my angle is equal to the opposite over the hypotenuse. And in this particular triangle, the sine of A is equal to the opposite, which is side A, divided by the hypotenuse, which is side C. And we know that the cosine of an angle is equal to the adjacent over the hypotenuse. So in this triangle, cos A is equal to the adjacent, which is side B, divided by the hypotenuse, which is side A. No, it isn't. It's side C. Okay, so I've got two expressions now. I've got the sine A is A over C, and I have got cos A equals B over C. So I need to work out, or I need to show that sine squared A plus cos squared A is equal to 1. So let's take our two expressions and square them then. So sine squared A plus cos squared A. Now that's the left-hand side, isn't it, of my thing that I need to prove. So my left-hand side is equal to sine squared A plus cos squared A, which is equal to my expression that I just found. So if sine A is A over C, then sine squared A is going to be A over C squared, and my cos squared A is going to be B over C squared. Yeah? Now, what does that make? So that is equal to A squared over C squared plus B squared over C squared. So I've got two fractions with the same denominator, so I can put them all over one fraction. So that's A squared plus B squared over C squared. Okay. Right, so I've got A squared plus B squared over C squared, but because we also know from Pythagoras theorem that C squared is equal to A squared plus B squared, that means I can replace A squared plus B squared with C squared if I want to. So coming back to my expression here, this expression here, A squared plus B squared, must be the same thing as C squared. So I've actually got C squared over C squared, and C squared over C squared is 1, which was the right hand side that I was trying to find. So we've done it. Huzzah! Like I say, this is an interesting result, and it crops up in A level, and you have to start getting very used to it. So there you go. Now you know where it comes from. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.